What's up, guys? We're back with another quick update video. Well, we'll see how quick it is. I had a lot of people asking me questions about the specifics of the system. It's very dead simple. At the heart of it lies your very efficient switching transistor. That will determine your efficiency. Right now I'm using a ZTX 450. Seems to be a little more efficient than the BC847C. And it's a very dead simple, heavily earth-grounded joule ringer circuit wound on a nickel zinc ferrite rod, 8 inches long, and the coil takes up 6.5 inches of space. And the wireless power it gives off is just phenomenal. It's very efficient. I've tried other designs. No design seems to be as efficient as this. I tried winding another one with thinner gauge wire. It didn't quite work out. I believe this one was built with 30 gauge and it wasn't nearly as efficient. So you have to build it with 28 gauge wire for your L1 and 16 gauge wire for your L2. So this is the Joule Thief transmitter circuit. And once you heavily earth ground it, the wireless power effects become phenomenal. It's a bit similar to a crystal radio in how it's earth grounded and how we tap the power wirelessly. Right now, we have 3 devices set up. We have a current meter in series with the negative output, so we can see the current being drawn is 4.6 milliamps from the battery. I can tune that much further, much lower. The voltage on the battery is 9.3 volts DC. We have the oscilloscope hooked up to our plate antenna here, a big resonant plate antenna. Our frequency is 198 kilohertz. And the way you tap excess power from this system is you bring a resonant receiver coil nearby. You make sure it's resonant with the correct capacitors. You install a full bridge rectifier on here, composed of 1N34A germanium diodes, or very efficient BAT43 or BAT41 Schottky diodes. And you can boost the power output even further by connecting the output of an insulated metal plate antenna to the DC output of the receiver coil's DC output. So again, you just connect the insulated plate antenna to either the negative or positive DC output of your receiver coil. And yeah, this is just a receiver, the feedback receiver that I have disconnected. I have the system set up in a simple way so you can see everything going on, and there's not a lot of confusion or questions as to how it's hooked up. You're getting a good look at it. It's dead simple. 9-volt driving battery, 330 ohm, 5 watt carbon film resistor, potentiometer. I believe that's a 30K potentiometer for fine tuning carbon film. And it passes through the current meter in series. Our negative output is in series with the current meter, feeding into our driving transistor, which is a ZTX 450, a little more efficient than the BC847C. That's at the heart of it. That determines how efficient you are. Giving off wireless power, you can see. And this wireless power effect, those amazing wireless power effects will not be present unless you heavily earth ground it. So as you see, we virtually have no wireless power anymore until I touch the actual part of the coil. And we actually draw a little bit more power when I do that. But earth grounding it suddenly makes the magic happen very efficiently. So now I will fine tune the device to the point where we consume nearly no power, less than 1 milliamp. And I'm tuning it with my potentiometer here. So we are now at less than 1 milliamp. I still have wireless power output from the device. which is absolutely phenomenal. I can probably fine-tune it a little further. Okay. So we're even less than 1 milliamp. And for those who doubt that this system is doing this, I will disconnect it, and the effects will go out. We now have no more wireless power. The system is out. No current consumption because it's disconnected. I will reconnect. We are reconnected. And to start the oscillations, you have to touch part of the transistor. So now we are back on with wireless power. Now, when I add this feedback coil, the way you add this resonant feedback coil for the most amount of power is you wind it like a transformer. You make it identical in length to the transmitter, and you take two conductors side by side, and you wind them same direction, and you make them resonant with the capacitors. And you connect this transformer in series with either your negative input or your positive input. And the other coil wound on this, because you wound two coils on here side by side, and one of them is series connected with the either negative or your positive input, and it's resonant. And then your secondary, the other coil that's wirelessly connected, will output power, and you can boost that outputted power by connecting a plate antenna to it, insulated plate antenna, to the DC output. Now, when I connect this up, we'll have a feedback power either slightly higher or equal to our input, and I can get my current consumption down to undetectable levels, and I can feed that power back into the DC driving battery, and I can get it to the point where the system is consuming what appears to be undetectable levels of power, yet we still have small amounts of wireless power being emitted from the device, and our battery either never drains, it sometimes drains, or it slightly recharges depending on the time of day, which is very interesting. And so we're in very low power mode here. The signal almost becomes undetectable when we run the system in very low power mode. It should be 198 kilohertz resonance. Why this is important is because we're trying to copy the Moray valve on some of its principles, and it's theorized Thomas Henry Moray achieved a type of transistor tube. Now, transistors didn't exist back when he was around. It's theorized he might have invented his own transistor with a transistor switching tube, and it was so sensitive it was nearly self-activating, or it was self-activating. And the way he stimulated that self-interaction or that self-activation within his transistor tube was from a heavy earth connection and an insulated antenna. Now this is where it gets very interesting that I discovered. He might not have been using an ordinary antenna. He might have been using what was called an electret style antenna. Now, an electret attracts additional charges to it from the atmosphere. So if there's a positive charge in the atmosphere, and if he made a negatively charged electret antenna, meaning he subjected it to high voltage as it was cooling down, or if he put his antenna wire in some form of oven, heated it up, and applied a negative high voltage DC to it as it was cooling down, his antenna wire, it would become an electret antenna, and that's electret, electret, electret. And what his electret antenna would do is it would draw in, the electret antenna would act as a giant net, drawing in energy from the ionosphere, from the atmosphere. So his big electret antenna, it would be just a wire, but it would be acting as a big square because you electrified it. There'd be a big electric field around the antenna wire because he turned it into an electret. And it's theorized it would be drawing in either a form of atmospheric induction once triggered, or it would be pulling in a form of oscillating. Either it might have been static energy, or it's some form of non-Hertzian energy. He was drawing into his device with a form of induction from his electret style antenna. That might have been it. We're not sure. Still a lot more research needs to be done, but that's the best theory on it using retroduction. It makes the most sense. And at the heart of it is your highly efficient switching transistor. So I figured I'd explain that, get that information out here. A lot of people might not like this video, but it's just to show you how efficient this system can be and explaining a few things. So once again, to sum up the Moray valve, he started out as a crystal radio set, and he was able to draw more and more power, significant amounts of power from it. He possibly used an electret style antenna to draw even more power out of the atmosphere, and it was known he heavily earth grounded his system, as well as had an antenna. Now, what's so important about this is if you can get a transistor, because the heart of this device is the transistor, and if you can get the utmost energy efficient transistor that is nearly self-switching, you can just keep duplicating the device, and the wireless power output probably becomes multiplicative in its effect, meaning your wireless power field gets more and more powerful the more you duplicate the circuit with virtually no input. Your nearly self-switching transistor is triggered into activation from your insulated plate antenna and your heavy earth connection. And you could just build another one of these circuits, connect it in parallel, and you should be off running, good to go. So, talking to some people, doing a lot of retroductive reasoning, and deep dives into the research, it's the number one theory is he made a electret style antenna to draw in non-traditional forms of energy from the atmosphere. And remember, this isn't an ordinary antenna. He made it an electret antenna, meaning an electric field is around the antenna and opposite charges attract, right? So his electret antenna is drawing in the opposite charge from the atmosphere, like a net around the antenna. Like a magnet has a magnetic field around it, an electret has an electric field around it. And his was drawing in charge from the atmosphere to activate his self-switching transistor tubes that he made homemade, which is the most impressive part. That's the theory. And he kept duplicating his circuits to get his power output to substantial levels. That's the theory. It might be true, it might not be, but that's the most logical theory, following common sense and retroduction. So again, to sum it up, the heart of the system relies on three things: an insulated plate antenna, preferably an electret style antenna, a heavy earth ground connection, wireless resonant receiver coils, and the system has to be designed with 16 gauge wire and 28 gauge wire. The primary coil, the L1, is 28 gauge, takes up 6.5 inches on the 8-inch long ferrite rod. The L2 is 16 gauge wire, and again takes up 6.5 inches, just wound over it in the opposite direction. L1 28 gauge, L2 16 gauge, and they're wound in opposite directions. So that's how we're looking. These meters are probably going to shut off soon. They shut off very quickly. We're drawing half of a milliamp and still have wireless power output, which is very phenomenal. Even touching it to, here's the resonant receiver coil. turn my meters back on. Put the lights back on. So, we just put this resonant receiver coil nearby. We have light output. So now I'm going to pause the video so I can hook this up. I'm going to hook this up so this coil is connected. Remember, there's 2 coils wound on here. We're going to connect one of these coils in series with the positive input, and the other coil wound on here will act as a wireless resonant transformer with a power output, and connecting the metal plate to the DC positive output of our wireless resonant coil boosts the power for free to us, and it allows us to do a feedback where I can turn the power down to virtually nothing and we still have a power output. So I will pause the video, hook that up, and get back to you. Okay, so we are back. I made the connection. There's 2 resonant receiver coils wound on here. One resonant receiver coil is connected in series with the positive input to the joule ringer transmitter circuit. The other coil acts as a wireless receiver that outputs power. Our power consumption now is 4.2 milliamps. I didn't fine tune it yet. Here's our output leads from that receiver coil. Having it next to the transmitter helps as well. I can connect an LED here, and I actually made the connection correctly the first time, which is kind of rare. That's funny. Now, to get this power even brighter at no additional input cost to us, what I can do is connect the metal plate antenna to it. So this is the lead for the insulated metal plate antenna. If I connect this to either the positive output or the negative DC output of the wireless receiver coil, our light gets brighter at no additional power input to us. So, as you see here, connecting the insulated antenna wire to the positive DC output of our receiver coil made the light get much brighter. Now, I will take this power, I will feed back this power back into the device, back into the source, and we should be able to fine-tune the power down to virtually nothing. So, I'm going to do that. Okay, now I'm going to try and fine-tune the power down to virtually nothing. And the correct way to do this would be to have a second feedback coil in series with the negative and some additional plate antennas. We'll see if we actually succeeded at this. And right now, the feedback wasn't strong enough to sustain it. I'm going to have to turn it up just a little bit. Okay, we're back on. It's a matter of very fine-tuning. This potentiometer is also a bit too large for the application. And there is a way to get it where it comes on and we consume no power. Not quite. I might need a second feedback coil, I'm not sure. But you're watching this in real time as I mess with the connections. So we have wireless output. I have to fine tune this just a little bit further. So we'll try that. And we might not get this to show properly in the video. This did show properly in my last video because I had more coils hooked up. But I'm giving you an explanation of how the system works and what goes on in it. So we have wireless power output at less than 1 milliamp input, and I'm struggling to fine tune it to the point where it draws no power but is still on. I achieved that in my last video. Something I will try and do is move the receiver a little bit further away. That could fix it. So I'll try again, because it's important to be in the far field when dealing with these types of things. So I'm going to turn all the way up and then try and tune it down. Trying to fine tune the last little bit of it. So we'll check that. Still outputting at 0.5 milliamp power consumption, wireless power. Try and get it to show nothing. Come on. I think it's on. Oop, no, we're still drawing power. We almost had it. It's a very fine line. Well, we'll try that. It's probably not working, but we'll try that. It's giving me difficulties with the fine tuning because I don't have the additional feedback coil hooked up. That's what does the trick. I thought I could do it with just one for this video to simplify the connections, but I guess I can't. I do need that secondary feedback coil for this to work in the video, unfortunately. But nonetheless, you witnessed wireless power output at virtually no input, 0.5 milliamp input. I'm going to end the video there. Again, to sum it up, insulated metal plate antenna will boost power when connected to the DC output of a resonant receiver coil. Another plate antenna down there in parallel with the first. Not really much to the system. It's dead simple. You just construct a joule ringer circuit. All the coils are 6.5 inches long, wound on an 8-inch long nickel zinc ferrite rod. A lot of people asking for information on how to construct it. You really just construct Laser Hacker or Laser Saber's super joule ringer circuit, except instead of running a load like he does, you earth ground the high voltage output of the coil. You leave the system open. You don't really put a load upon the system and have it run a load. You tap into the system wirelessly and resonantly with your receiver coils or your other wireless lights. You want to keep no load upon the transmitter circuit, and you earth ground it, and in theory you're making it nonlinear. It should resonate with the earth by earth grounding it, because the Joule Thief is an automatic, it automatically tunes itself, and the key to it is the very efficient transistor. Right now we're using a ZTX 450. If we can get an even more efficient transistor, maybe switch to a MOSFET, the system will become even more efficient. And what's mind-boggling is the system outputs wireless power when heavily earth grounded at less than 1 milliamp. I had it to 0.02 milliamps before, outputting wireless power. Now, if that's not a form of over-unity or a form of a nonlinear effect, I don't know what you would want to call that. So again, to sum it up, people asking me a million questions on how to build it. It's just, you get an 8-inch long nickel zinc ferrite rod. You don't even need the Met glass laced ones anymore, although you'll have a small efficiency boost with Met glass. 8-inch long rod. You center your two coils on it, wind them even. The neater you build it, the more efficient the system will run. Your L1 coil, which is your thin coil, is 28 gauge wire. Your L2 coil is 16 gauge wire. Has to be those two wires. It won't be as efficient with any other wires. Not sure why that is. That's how the transistor looks. Really simple to hook up. I might sell these for on the site for maybe $150 if people don't want to build them. It's just dead simple ringer rod, I might call it. Wireless power ringer rod, very efficient. So yeah, it's very simple. Thank you everyone for liking, commenting, subscribing. Feel free to subscribe, join the channel. Our goal is to become a research company, hopefully one that leads in highly efficient energy systems. And yeah, we'll see what happens. And thank you everybody. Hopefully I explained everything and summed it up. About the Moray valve, how he probably had an electric-style insulated antenna acting as a net, drawing in more power from the atmosphere, along with his heavy earth connection. He was probably drawing in non-Hertzian energy, and the key to it, the heart, the absolute key in the heart, is your near self-switching transistor, nearly self-activating or self-switching transistor. And he probably achieved that with a tube-style transistor that he probably developed himself or had a company develop for him. And he might have been using a rare form of galena, maybe argentiferous galena. It was known as being soft white, but we're not sure yet. We're trying to delve deep into it and figure out what he was exactly using. It probably was a type of galena, but again, we don't know. We don't have confirmation. But nonetheless, showing you everything I did here, it should be nearly impossible to have wireless power output at less than a milliamp of input. That's highly efficient, worth studying. And yeah, feel free to check out other people like Joel Legase, Inventor 3, Theodore Apophis, Ken Wheeler. A lot of people doing good work out there, countless others involving energy. Basically, these systems, once activated, act as non-Hertzian inductors to the environment. So once activated or once triggered, these systems act as non-Hertzian inductors to draw in power from the environment. And I'm really trying to fine-tune this system. If I can find possibly an even more efficient transistor than the ZTX 450, that'd be phenomenal. Because it almost seems as if the act of the transistor switching is the catalyst for energy manifestation in the receiver coils. The more efficiently we can do that switching, the better wireless power we will have. So, when in operation, this system produces no heat, it's nearly as efficient as possible, draws as little power as possible, and produces phenomenal wireless power effects due to the high Q resonant nature of the system. And again, Maxwell's traditional electrical equations don't pin a direct link between cause and effect between certain electrical phenomenon. So again, thank you everybody, and hopefully we can keep cracking these secrets together, and feel free to like, comment, subscribe. And it might have been a bit of a boring video, but it was to show you principles, concepts, explain things. And yeah, get you building stuff too. So again, it's just 8-inch long nickel zinc rod. Your L1 is 28 gauge. Your L2 is 16 gauge. L1 and L2 are wound opposite to each other, and you're good to go. You follow the Laser Hacker Laser Saber schematic how to build it. You're in business. Just make my modification where both coils take up 6.5 inches, and you heavily earth ground the L1 output, which is the thin coil, the high voltage output. In Tesla's old style system, the earth always becomes hot in his style of energy transmission. The earth becomes hot. So thank you everybody, and again, we'll see you next time.